Okay, today we're going to talk about reflections. Is this like a reflection in a mirror? Well, a little bit, but it's definitely like taking a equation like y equals x squared and then making it have a negative on either the inside or the outside, which can kind of look like this. And here's a negative going on the inside versus a negative going on the outside of the function. And do you remember that it was horizontal on the inside and things that were on the outside were vertical on the outside? And a parabola normally looks like this. And if you do a reflection on the inside, that's horizontally. That's like taking this parabola that's going like this and then flipping it this way across this axis. But if I make it flip across this way, it's going to be right on top of itself. So you won't even be able to tell it flipped. Whereas if you take this kind of reflection and you do a vertical on the outside, vertical, I hope you know this means up and down. If I make it flip up and down, then my new parabola would look like that. Now that is a reflection. Okay, so there's the brief intro to some of the stuff you're supposed to remember and now what we're going to do with it. All right, everybody get to this page, and I'd like to see if you remember this graph. And if you don't remember that graph, make an XY chart, find a few points that are on it. There's quite a few points that wouldn't work, but find some that would work and graph it. I'm going to have us pause for a minute until you graph that first square root graph. Okay, I hope you remembered that it looked kind of like that. If you want to get specific, if you put in 0 into this function right here, you get 0. You put in 1, you get the square root of 1, which would be 1. If you put in 2, it's kind of difficult because you get this weird decimal. So then you probably jumped up to 4. If you put in a 4, you got square root of 4, which was 2. And the next one that works nice is 9, because then when you put a 9 in there, the square root of 9 is 3. And those points get graphed. One there, and then 4, 2 is basically there, and 9, 3. It looks like I went up a little too high on that last one, but okay, so there's what the square root graph looks like. Now what happens if I put a negative on the outside like this? You can go back and take the original one and take all of its original points and make it reflect. But I want you to just have the big picture in mind here. This is on the outside, so it's a vertical, high vo, vertical on the outside. If the original one looked like this, and you do a vertical reflect, I want you to draw where you think it would be. We'll pause for a second and see if you can figure out where that should be. Okay, vertical, you should be thinking up and down. That's what vertical means. Horizontal is like the horizon, and that goes like this. Well, we were doing vertical, so we're not doing this one. All right, now we're going to make it go like that. That's kind of the big picture. It's a reflection vertically. So that goes across the x-axis. This is the x-axis here. Okay, now what if you needed to get exact points? You can always make an XY chart. I call it your best friend in graphing. So if you want to just stick in some points on that graph, like stick in 0 and see what you get, you might be like, but there's a negative out there. What's negative of the square root of 0? So that would be negative of 0, which is still 0. Okay, now how about if I put in a 1? Well, I put the 1 right there, and it's the negative of the square root of 1. Now, some people might be thinking, are you saying the square root of negative 1? No, the negative's on the outside. And so the square root of 1 is a real thing, and then I just make it negative. The square root of 1 is 1, and then I make it negative. So now I have negative 1. And do you see how if I go 0, 0, it's right on top of where it used to be? And if I go to 1, negative 1, look at that. I'm right on top of that line that I just drew in blue. Okay. What if I put in a 4? Then I get the square root of 4, but it's negative in front. So negative square root of 4, so negative 2. And that's over 4. And 1, 2, 3, 4, down 2. It's right there. Okay. This one's negative is different because it's on the inside. And so this is a, remember, HIVO, horizontal on the inside. So the original square root graph looked like this. And this new one horizontally flips. Sometimes we call it flip, even though it's officially called a reflection. It looks like that blue one. How would I know? If you want to get exact points, which you will need to do on this next test, if you just sketch them like I just did, you will not get the full credit. So you have to have points. So if I put in, for instance, 0, I have square root of negative 0, which sounds kind of weird, but negative 0 is just 0, and the square root of 0 is 0. So look, they share that point. Now if I put in negative 1, some kids think that this whole thing is impossible because there's a negative. But really, let me blow this up. This is important. It's the square root of negative empty parenthesis. That's what the x is. X's are empty parentheses. This is so important because now it's an empty parenthesis. As long as I put in a negative number, like negative 1 here, then I got the square root of negative 1. The two negatives cancel. Square root of 1, which is 1. So negative 1 comma 1 is a point. Negative 1 comma 1, look at that, it's right there. How about if I put in negative 2? Well, that's not a great idea, server, because negative 2 ends up giving you square root of 2. And that's some decimal that nobody knows. So let's go to 4. Because negative of negative 4 will make it positive 4. So negative 4 goes in, and then I get the square root of positive 4, because there was 2 negatives. And square root of 4 is 2. Negative 4, 2. And let me put a dot there. Okay, you getting the idea? So if you just like forgot everything and you were like, I don't even know what this means anymore, even though one of them's horizontal and one of them's vertical, well, you should be able to make an XY chart, stick in some numbers, and see what you get. All right, I'm going to have us pause and everybody give this one a shot. If you have to, just stick in 0 and 1. Just keep on putting in numbers and finding what the answer is. Eventually you realize you got to put in negative numbers or this thing isn't going to work, because you need to have negative of a negative in order for your square root to work. Okay, so I'm thinking at this point you put in 0 and you got 0. I'm thinking you put in positive 1 and you realized if you put positive 1 in here, I want to make sure you get this. If you put positive 1 in here, you're saying that the x, remember, it's the x has an empty parenthesis. Then when you put a negative 1 in right here, or sorry, a regular 1, sorry about that, a regular 1 goes in there, then you would have the square root of negative 1, and that doesn't exist. You can't do the square root of a negative. So DNE, do you remember me saying that does not exist? Another way to say it is no solution. All right, so we're going to now put in negative 1. Can that work? Yes, because then I have a negative of a negative. So I have negative of negative 1, and then that makes positive 1, and it's the square root of positive 1, and it's the opposite of that. So that comes out to negative 1. Now, if I just simply graphed these points, I could eventually find it. So I'm going to see, though, if you can think about, here's what it normally looks like. That's normally what a square root graph looks like. I usually make it pop up a little faster than that, so I'm going to try that again, kind of like that. Then, if you just kind of think about where it should it be vertically reflected? Yes, but also then horizontally reflected. And so I'm hoping that you could see this graph would go like that. Okay, erasing out all the little directional arrows and stuff. The red one turns into the blue one. When you do a double reflect, one horizontal and one vertical, you got to do both. Now some kids might say, well, I made it flip over here first. Well, great, then you got to make it flip down and you'll be in the same spot. Okay. All right, now what's a way to do all your homework problems without even totally understanding the horizontal and the vertical? Just putting in points. If you can just make some points by sticking numbers in here that you pick, then you just have to graph the points. If you graph as many as 4 or 5 points, you'll absolutely know where the answer's got to be. All right, so what about this one? There's a negative. First, let's talk, is that horizontal or is that vertical? Everybody pause for just a second and think, what should this look like? You should know what a parabola looks like. All right, so parabola looks like this. And what should this look like? Well, we got a negative on the inside. It's a horizontal on the inside. And I gave you this at the very beginning. If you reflect this way, it'll be, when you flip it around, it'll be right on top of itself. It's kind of a weird concept. But this side here would go to the right, and this side here would go back to the left, and you'd have the same thing you had in the first place. If you think about why that is, if you really think about it, whether this thing was negative or positive didn't matter because you're squaring it. So whether you put in +1 or -1, once you square it, 1 squared is 1, or -1 squared, also 1. So it really didn't matter that you put a negative inside. And so the graph does not change. If you make enough points, put in 2, and you get this -2 squared, which is 4. And it wouldn't have mattered if you'd have put in -2 or +2. I put in -2. -2 times -2, +4. And when you graph it, you would end up getting the same thing you had in the first place. So if I graph all these points, like 1, 1, and 2, 4, they're all points that'll be on this new graph. And there you go. 0, 0 would even say the same. All right. So I hope by now you remember that when you have a change, like let's say negative square root of x plus 5, if that's on the inside, is that, well, it's high, and then low. So that's a horizontal change. And in this case, it feels like that should be 5 to the right, but it's actually 5 to the left. The things on the inside always do the opposite of what you would expect. All right? And which way is this negative here? That is a vertical on the outside, a vertical reflect. All right, so the key here is the high and the low. And so if you're inside versus outside, you end up with different answers. So if I were to give you one here, and I put a square root of 6 plus x, hint, that would be the same exact thing as x plus 6, minus 8. If it's a negative on the inside versus a positive on the inside, see, this is the inside one. If you have a positive on the inside, remember that was like this one, that means left. If you had a negative on the inside, Oh, heck, I'll just change this one and make it have a negative on the inside. X minus 9. Negative on the inside means go to right. If you're on the outside, that's like out here, and you add something, that goes up. If you subtract something, that goes down. If you have reflections on the inside, horizontal on the inside comes to mind. Yep. And vertical on the outside. Okay. If they just ask you to describe it, it is so easy. You just say, oh, that one's going down. Remember the ones on the outside, up and down. And those are vertical moves. Vertical on the outside. This is horizontal on the inside. So that is a horizontal reflect. This 7 here fools so many people because they see the 7 and they see the minus and they think -7. No. That's a +7. That negative is on the parentheses. So if you move to the end, I think you'll do a lot better on this kind. Take that 7, move it to the end, and then you'll realize, oh, it's just up 7, and that means left 2, and that means if you're stuck like, oh, is it horizontal or is it vertical? Repeat to yourself, horizontal inside, high, or vertical outside. Clearly that is a vertical. And if you couldn't think of anything else, at least put down vertical. Maybe I could give you part credit. It's a vertical reflect. If you had said vertical flip, I might have been able to take it. I don't know how tough we're going to be on the word flip versus reflection. Okay, so if on the other hand, they ask you to write an equation for something, then they want you to start with f of x, and then they want to just say, okay, how has this thing been moved? It was absolute value of x, but I want to go right 4. Oh, so you're saying I should put a -4 here. And a vertical reflect? Which way would vertical be? Vertical was that on the outside? Oh yeah, high, Yep, that's a vertical reflect. Okay, now let's talk about its domain and range. This is important. If I'm able to make a sketch of it, you'll be able to get the domain and range so much better. Okay, so here's my little picture. And the domain, remember that's about the x. The domain, how far does it go in the x direction? It goes forever in both directions. Negative infinity to positive infinity. And the range, that's from how low to how high. How low is this? From 0 to how high is this? This function keeps going forever. See the arrows on the end? It keeps going up forever to infinity. All right, so now I think we should do one more like that. Let's say I had y equals negative square root of x plus 4. If I had asked you to graph it, you would have busted out the xy chart. If I had asked you to tell me which way it got reflected and moved, I hope you could have just looked at this and said, okay, even if you get stuck, some kids are going to say right away, they know it's left. Okay, but if you're not sure, you just have to think, okay, horizontal inside, vertical outside. If you were just asked which way did it move, you'd have to think those through. And last but not least, if they asked you to take this function and move it up another 6, you'd have to be able to take it and go, oh, I wanted to move up 6, then I put a +6 on the outside. All right, so let's see if you can handle one. Y equals square root of x minus 1 plus 6. Notice that's on the outside with a negative in the very front. Okay, your first step, just tell me which way it went. Left, did it go right, did it go up, did it go down? Did it reflect vertically or horizontally? Pause for a sec while you write down which way did this one move. Okay, I'm hoping that you knew that this was up 6. This was right 1, and that is horizontal. No, wait. I corrected myself because I quick in my head said high-vo, vertical on outside. That is a vertical reflect. Now everybody, take a minute and find just 3 points that are on this. And hint, don't put in 0 because you're going to end up with square root of -1 and that doesn't even exist. So you better bring your A game here. 0 does not even exist. Can you find me 3 points that actually exist? Now pause for a sec and we'll see if you can get 3 points that exist. All right, so I'm hoping you tried 1 and realized that 1 actually works pretty well. Once you put the 1 in, you get square root of 0, which is a real thing. It's 0. -0 is the same exact thing, but don't forget to add 6. If you had a 0 here, you forgot to add 6 and make it 0 plus 6 is 6. All right, there's one of my points, 1, 6. Now, it's really common for kids to go put 2 in, but I hope some of you caught that 2, wait a minute, that's actually going to work. I thought it wasn't. Square root of 2 minus 1 is the square root of 1. Square root of 1 is 1. Then I make it negative. -1 plus 6. -1 plus 6 is 5. I've got 2 points so far. Got to get one more point. Now putting in 3 is the thing that I thought would mess it up before. Because when you put in a 3, you end up with 3 minus 1 is 2, and the square root of 2 is some weird decimal that nobody knows. So we shouldn't put in 3. It's not like it doesn't exist. It's just a weird decimal that you don't want to try to figure out. All right, so we're going to go to, would it be 4? No, 4 minus 1 doesn't work out real nice either. Square root of 3, who knows what that is? How about 5? That's going to work. Because when I put in 5, I get square root of 5 minus 1 is 4. Square root of 4 is 2. Then make it negative is -2 plus 4, or plus 6 is 4. And look at that, I found 3 points. If you had just asked me which way it would go, I'd think it's going to go up 6 to the right 1 and vertically reflect. But if you wanted exact points that are on it, that's the way you get them. All right. I'd like you to try this one. You're supposed to write an equation for this. You take this as a starter and then move it up 7 and horizontally reflect. Then make a quick sketch, not an awesome perfect graph, a quick sketch, and figure out the domain and the range. I'll pause for a second while you give that a try. Okay, first off, square root moved up 7. Square root of x moved up 7 is plus 7 on the outside. And a horizontal reflection, horizontal is on the inside, high-vo, right? So this has a horizontal reflect, so the negative right there on the inside. That's my equation. You could say f of x, or you could say y equals. Okay, now if I make a quick sketch of this, again, this is not meant to be perfectly accurate. A normal square root would go like that, and you're supposed to have that memorized. Now this negative is going to make it flip this way, and then plus 7 moves it up 7. So now my square root, that didn't look real nice. Let's try again in red here. As long as I moved up 7 there, there's my square root. Moved it up 7 from its original spot, and it's flipped. There's my answer. Now, if I needed exact points, I would go get out my XY chart, but I don't really need that. I just need the domain and range of this graph right here, this guy. Okay, the domain and the range of that. The domain is, it goes forever to the left, because remember, domain is left, right. and it's forever to the left, which makes negative infinity. And how far to the right does it go? It doesn't go forever. It stops right there, which is at 0. Remember, if it touches that spot, you put a bracket on it. Okay, now how about range? The range is how low to how high, and the lowest this graph goes is this spot right here, which is at 7. And the highest this graph goes is infinity. So 7 to infinity. We're all boys and girls. XY chart, but something's wrong with this XY chart. This is the original square root XY chart. If you go put a 4 in, for example, right now, you will not get 2 for your answer. Okay, so I think it's best to just not use these original points and make up your own points, because the teacher was trying to make you do like 12 steps. They were going to make you find the original points and then move all the points and then flip all of the points, which means basically multiply on the inside by a negative. But we don't want to do that. It's so much easier to just pick some points. You get to pick anything you want. Just realize that if you put in the wrong thing, like 1, if I just pick 1, then I get the square root of negative 1, and it does not exist. Okay, so maybe 0. Yep, 0 works. Square root of 0 is 0. Negative 0 is still just 0. And then if I have 0 minus 3, it's negative 3. What if I put in a 1? Regular 1 wouldn't work. Remember, when you put something into the x, you're only replacing the x, nothing in front of the x. So that negative that was there, it stays there. So if you put in let's say a negative 1 here, I'll end up with the square root of negative 1. That would work. But regular 1 did not exist. So I can put in a negative 1 though, because now I have negative 1. Which makes positive 1. And positive 1 minus 3 is negative 2. So I put in a negative 1, I got negative 2. If you do that enough times, you find out where your graph is. Now I could generally know that this was a square root that had been moved 3 down and had been horizontally reflected with that negative. So here's the horizontal reflect. You know, horizon is like from left to right, so this is a horizontal flip. And then it has to move down 3. So I could tell you, generally it's down there. But if you want to get exact points, the XY chart is your best friend in graphing. So you're going to need 5 distinct points typically on your graphs. All right, I'm going to go to this slide 10, and it looks like this. So that's where we have an absolute value, and these are the parent absolute value points. I'd like you to scribble them out, because in my opinion, having to find all of those and then change them all to be the opposite and then change them all to move up 3, that's just crazy amounts of work. I think you should just start by picking numbers like 0, see what you get. 1, I'd like you to put in negative 1, and 2 and negative 2. Okay, everybody put in all of those numbers, and we're going to pause for a minute. And I know you're probably tired and sick of this, but we're pretty much done here. So give me your best shot to find what would you get when you put in 0 and 1 and negative 1 and 2 and negative 2. Okay, we're back. You stuck in 0 and you got 3. When you stuck in a 1, you get negative of the absolute value of 1. So that's negative 1 plus 3. Negative 1 plus 3 is 2. Now what if I put a negative 1 in here? Well, the absolute value bars are going to make it positive. Then you have another negative on the outside. Brings it back to negative 1. Then we add 3, positive 2. How about if I put in regular 2? This is getting kind of messy, so I'm going to clean it up. And I'm going to put in 2. There's my 2. Now it's negative of the absolute value of 2, which is negative 2. Negative 2 plus 3, positive 1. And you know what I'm going to know? That this is also going to be positive 1. Why? Because if I put in a negative 2 and I do the absolute value of it, it's exactly like I put in a regular 2. So I get the same y value out. And if you can graph, these 5 points, then you'll know exactly where this thing is. You should have known it was a V shape because it's got an absolute value bars. And it's been horizontally reflected and moved up 3. But here's what it actually looks like. Over 0 and up 3 would be a dot right here. Over 1 and up 2. Over negative 1 and up 2. I bet you anything this is an upside down V shape. Look at that. With a move up of 3. Well, look at that. The V shape is moved up 3. Look at this. It would just keep going and going and going like that. It's an upside down V shape that's been shifted up 3. Who would have known? Okay, domain, that's left to right, and it goes forever in both directions. The range, that's how low to how high. Well, remember you always start with low on the range. The lowest it goes, negative infinity. The highest it goes is 3. Now, if you keep practicing this, the test is in about a week, beginning of next week, and so you have about a week. But you need to get good at finding points. I'd say that's the number one thing. And the new main thing for today was what happens if they put a negative in here, and that's on the outside, so it was a vertical on the outside. Horizontal stuff happens on the inside, and this was our vertical flip. Our original graph would have been a normal V shape, and it flipped like this. And that was a vertical reflection because of the negative in front. All right, this is just a summary page that talks about everything we already did, and I don't think we need to reread all of that. I'll just put you to sleep. So you have a Schoology quiz, which is what we just started. I'm going to have the sub take a look and make sure in Schoology that each of you logs in and gets started on that Schoology quiz. For the help for the sub, if you just take a look at the Schoology quiz and the results tab, you'll be able to see who has opened up and started their Schoology quiz. All right, you guys, good luck, and I look forward to seeing you again soon.